our lesson on logical IP addressing. IP addressing is an essential component of network communications that enables devices to locate and identify each other on a network. In today's session, we'll embark on a journey to unravel the complexities of IP addressing and understand how these unique identifiers are structured and utilized in various networking scenarios. First, we'll delve into the anatomy of an IP address. We'll dissect its notation, learning how to read and write IP addresses in both their familiar dotted decimal format and their underlying binary representation. Next, we'll tackle the distinction between public and private IP addresses. Understanding this difference is crucial in grasping how the Internet functions as a global network and how internal networks maintain security and efficiency. We'll explore how these addresses are used in modern networks and the significance of this demarcation in network design and Internet connectivity. Following that, we'll explore the Dynamic Host Configuration Protocol or Dynamic Host Configuration Protocol, a vital service that simplifies the management of IP addresses. You'll learn how Dynamic Host Configuration Protocol can be configured to allocate IP addresses automatically to hosts within a network, and how it can also assign specific static IP addresses when needed. This segment will cover both theoretical and practical aspects, ensuring that you are well-versed in the mechanisms of IP address distribution. Finally, we'll get hands-on with allocating IP addresses. We'll go through the processes of manual and automatic IP address assignment, providing you with a comprehensive understanding of how network administrators control and distribute these pivotal network identifiers. By the end of this lesson, you will not only be well informed about the different aspects of IP addressing, but also be equipped with the practical know-how to apply this knowledge in real-world networking situations. Let's begin our exploration into the world of logical IP addressing. Click Next to continue. An IP address is a string of numbers, typically expressed in a dotted decimal notation, and serve two primary functions. The first function is network identification. An IP address provides a unique identifier for a device within a network. This helps distinguish one device from another, allowing data packets to be accurately addressed and delivered to the intended recipient. The second function is location and routing. IP addresses play a crucial role in routing data across networks. Routers use IP addresses to determine the best path for data packets to reach their destination. They examine the destination IP address in the packet header and make forwarding decisions based on routing tables and protocols. There are two versions of IP addresses in use today: Internet Protocol version 4 and Internet Protocol version 6. Let's take a look at each. IP version 4 addresses are 32-bit binary numbers, typically represented in a decimal format consisting of 4 sets of numbers separated by periods. This address consists of two parts. The first part identifies the network. The second part identifies the host on that particular network. Each set can range from 0 to 255, giving approximately 4.3 billion unique IP version 4 addresses. Despite this seemingly large number, due to the growth of the Internet and the increasing number of connected devices, the number of IP version 4 addresses have become limited in availability. Select the next option. Internet Protocol version 6 is the latest revision of the IP Communications Protocol. This protocol was developed by the Internet Engineering Task Force, or IETF, to deal with the long-anticipated problem of IP version 4 address exhaustion. IP version 6 expands the length of an address, allowing for many more unique addresses. The size is quadrupled to 128 bits, giving a maximum of 3.4 times 10 raised to the power of 38 possible addresses. These addresses are represented as 8 groups of 16-bit hexadecimal numbers, separated by colons. Half of the IP version 6 address is used for the interface ID on a device. This interface ID can be adapted from the media access control address of the host, set through other means such as Dynamic Host Configuration Protocol. To make an IP version 6 address easier to read and interpret, There are a couple of acceptable methods of shortening the length. First, you can remove the leading zeros, as these are optional. Second, RFC 3515 indicates that if there are one or more fields of 0 in a row, a double colons can be used to represent the fields of 0. Click Next to continue. Unlike MAC addresses, which are given to the network hardware by the manufacturer, IP addresses are assigned within networks either manually or automatically. In addition to decimal dot notation, IP addresses can also be written in binary notation, which only uses zeros and ones. The binary notation has a series of 8 zeros or ones referred to as octets used to represent each of the dot-separated decimal equivalents. Each position in the octet has an inherent value, which corresponds to a specific power of 2. Let's take a look at the IP address 192.0.2.24 and the first octet. The first position on the left and the most significant bit is valued at 128, which is 2 to the 7th power. In this octet, it is assigned a value of 1 because it contributes its full value. The second position is valued at 64, or 2 to the 6th power. We'll also assign a value of 1. Let's now add the values we have so far, which is 128 plus 64, which gives us a total of 192, also the value of our first octet. For the remaining 6 bits, we'll assign a value of 0 because they contribute no value to this octet. Now it's your turn. What is the binary equivalent of the second, third, and fourth octets of our IP address? Option 1. Second octet equals has 8 zeros. Third octet 00000010. Fourth octet 0001111000. Option 2. Second octet equals 00000001. Third octet 00000110. Fourth octet 0001110000. Option 3. Second octet equals 00000001. Third octet 00000100. Fourth 0000011000. Option 4. Second octet equals has 8 zeros. Third octet 0000001000. Fourth 0000011000. Select the best option. Now it's your turn. What is the binary equivalent of the second, third, and fourth octets of our IP address? Option 1. The second octet has 8 zeros. Third octet equals 000000010. Fourth octet equals 0001. 5 types of IP addresses in the IP addressing system, which are defined by the first octet of an IP address. These 5 classes are A through E, and they were originally used for specific purposes and functions. However, their usage has decreased over time as we have shifted towards the classless inter-domain routing or CIDR notation. Click each class button to learn more. Class A was designed for networks with a small number of subnets with large numbers of hosts per subnet. Class A's range is 0.0.0.0 to 127.255.255.255. The first bit is always 0. An example address is 15.125.75.45. Select the next option. Class B was designed for networks with a larger number of subnets but with a fewer number of hosts per subnet. Class B's range is 128.0.0.0 to 191.255.255.255. The first bits are always 1 and 0. Example, 150.125.75.45. Select the next option. Class C is most suitable for smaller network sizes and large networks with few hosts per subnet. Class C's range, 192.0.0.0 to 223.255.255.255. The first bits are always 1, 1, and 0. An example, 200.125.75.45. Select the next option. Class D is reserved for multicasting. In multicasting, data is not destined for a particular host. For that reason, there is no need to extract the host address. Therefore, Class D does not have any subnet mask. Class D's range is 224.0.0.0 to 239.255.255.255. This class is used for multicast groups, not for standard network interfaces. The first bits are always 111 and 0. An example address is 224.0.0.1, which a well-known multicast address. Select the next option. Class E is reserved for experimental purposes only. It also does not have any subnet mask. Class E's range, 240.0.0.0 to 255.255.255.255. This class has also been reserved for future use, experimental purposes, or research and development. The first bits are always 111 and 1. An example Class E address is 250.125.75.45. Click Next to continue. Subnetting is the technique for logically partitioning a single physical network into multiple smaller subnetworks or subnets. When we assign an IP address to a device, we also need to specify a subnet mask.